So today I'm going to have it out our project for the Fortran Package Manager, which we are trying to build to get towards a rich ecosystem of Fortran packages. So I'm Sebastian, presenting this joint work of a group of volunteers at the Fortran Latin community. You can find us on GitHub at Fortran Lang. So the 3 points I want to talk about today is why we want to have a package manager for a language like Fortran, how we implemented our package manager, how far we got already, and a bit of outlook where we want to go. So maybe I should start this talk by explaining what Fortran actually is. Because maybe it's not that well known anymore, but Fortran is in fact the first high-level optimized cross-platform programming language, and it was developed by John Barker's team at IBM in 1954. So this is quite an old programming language, actually, I think older than C and languages like Lisp. And it was originally created to ease the translation of mathematical formulas directly into machine code. And it has been and is still very successful in the scientific computing community. So many scientific applications libraries are developed in Fortran. And the language is still under active development, the latest standard being 2018. So our motivation to build for an existing language a package manager is that building and distributing Fortran software is difficult. It's not impossible to do it with other strategies. Many build systems do support Fortran, and there's CMake, there's Meson, AutoConf, which you get to work, but most Fortran developers are actually more scientists rather than really familiar with all those tool chains. And sometimes writing of those build files and adjustments for Fortran can be quite time intensive, and this makes it somewhat difficult or tedious to reuse Fortran source code. The other issue which we have in the Fortran ecosystem is that system-wide installation are a bit dangerous if you're using multiple Fortran compilers, and most Fortran developers are using at least 2 or 3 compilers for their projects, because there's no real ABI compatibility between different Fortran compilers, which made it in the past somewhat impossible to depend on a project without redistributing it, which makes it is not quite a good thing to have. So we decided we want to have a Fortran-specific build system and package manager to fix this, to make it easy to create and distribute reusable Fortran libraries, which we started with this project, FPM. So we can consider this primary build system and productivity tool for developing Fortran. And some of the challenges about Fortran is that we have modules which we are using to share symbols between packages and source files. And we have those since Fortran 90. C++ added those in, I think, C++ 20. And Fortran also had something like submodules, which allow to provide implementations. And due to these models, we don't really have header files, but those modules are how are the interdependencies between our source files we need for the compilation order. And to make the information about the symbols available, you have to install these module files. But since we don't have AB compatibility and no standardized module format, you have to make sure that the compiler doesn't pick up the module files from a different compiler. So these are the constraints we have to look into for building a Fortran build system which takes care of this. Usually most build systems are not really tailored for this challenge. So one thing to do was selecting a language to implement our package manager. And one of our aims was to find something which is fast, which often not overhead. So usually we look for a compiled language here. It should be self-contained and simple to set up. So preferably a small runtime library or static binaries. And we wanted actually to make it easily accessible for our users to contribute back, which are mostly Fortran developers. Since most Fortran developers are familiar with Python and C++ as well, those are obvious choices. Python doesn't really qualify for being that fast, and maybe not also easy to set up. So we want, looking more into compiled languages, we started drawing some inspiration from Rust and Cargo. So we started implementing our first prototype in Rust, and at some point switched to Haskell for implementing. But those two languages in our community have the problem that we don't have many developers familiar with this. So in the end, we decided to actually implement our package manager in Fortran because it's the most well-known language in our community, and compilers can easily produce static binaries for our distribution. And well, Fortran has been around for a while. There's not really wasn't really a community around actively developing the tooling, but more individual library developing. And we want to use this opportunity building package manager, building a large standard library, and trying to improve in this process the language and our tooling. So, of course, building a language package manager means that we are building the package manager with itself, and which makes a lot of sense since we're writing it in Fortran and we're using it as Fortran Package Manager. Building it with a Fortran compiler would be the only thing the user for sure has available on their system. And we could boil it down for minimal dependencies requiring only a Fortran compiler to build it from a single source file, which is just download by some means, maybe called an compiler review, Fortran compiler of choice, and then use this binary to bootstrap the installation, which then requires a bit more because we want to interface with some C libraries, and maybe need to fetch dependencies, which we're currently doing via Git. So how far is our community with building those? Our compiler interface currently features a couple of things one expects in a package manager. Like we have to build a Fortran project which follows our standard layout. For handling modules and submodule interdependencies, automatically finding all our executables and tests. Then, and of course, we can just directly run our Fortran project out of the source. Again, with something which you would expect, you can make a selection, use globbing. Of course, software projects have to be tested. Fortran is no exception there, so we provide easy integration with unit tests to find and run test executables, allow them to run them in a debugger. And of course, if this all works, projects can be installed. And we follow this strategy like it came up with npm. We install a user prefix by default. And to make sure users get easily into our package structure, we provide a command to actually create new projects and also backfill existing projects with our layout. And then, of course, we have a dependency management, which was updating and building a basic caching logging. So our inspiration was mainly taken from Cargo. So we went with using a package manifest internal, which is to limit the complexity of the build files and only contain mainly metadata of the projects. We impose a default layout, which allows FPM to automatically find everything, and but give the user the possibility to customize this to their liking. We can automatically draw our names for the executables if there are multiple from the respective program units we find in the source, and of course we can still link system libraries. And one thing which was important for us is we want to have first-class dependencies, which also help with the issue, which kind of solve the issue of the RB compatibility we have with Fortran. And right now we're specifying our dependencies to reference other projects, like by git URL, and we provide different scopes to set dependencies for development or for for just a single executable. And finally, since probably we are far from perfect with our starting our effort on this package manager, we allow to customize plugins to make it easy to stage new features. And we try to pick them automatically up from the command line and pass through all the options we got. And so far, we got a few features. So one is currently for staging our registry, which we're trying to build, allows us to download registry data, search for packages, and include in the manifest. And other thing is mainly for documentation. Some of you might know the Linux man command for manual pages, and what we built into FPM with a plugin was the documentation for all the intrinsic commands we get in Fortran. So from your build system, you can just check the documentation of everything without leaving without looking somewhere else. So FPM is kind of new, given the languages has been around for a while, and we started this effort in last year in May with our Rust prototype, which we then around the Fortran Con in June switched for the Haskell implementation. And we quickly realized that while Haskell is working nicely, we didn't have enough developers to actually follow up on this. So with the first release, which I marked here in the graph, we switched to a Fortran implementation, and this gave us some traction in the community, and we are now at 200 open source projects already using FPM. And I checked most of them, so we're still a pretty small ecosystem, so I'm able to check all of them. And there are like 170 unique developers who contributed there, so not all from the same person. FPM for up to now has 62 contributors, and we have code contributions from 21 developers up to now, and we are hosting it on GitHub in a T-license project. And one thing we try to do is to be compatible with package managers, so from the very beginning. So we are already available in Spark, we are Conda Forge, available on Windows and MSys2. I'm hosting a homebrew tab to distribute FPM as well. So this is where we stand with our project for building Fortran, the Fortran Package Manager. And so, of course, at this point, it's a very early stage for us actually developing this tool. We are still looking into a good way to create a registry for all our Fortran packages where we don't have to reinvent everything, but use existing tooling. And also, one thing that is important is we want to integrate from the very beginning with other packaging ecosystems. So making it more like a productivity tool, which allows you to build your software and then easily integrate with and allow to distribute the software via Conda. And I think since we have a lot of Fortran compilers, we want to have also provide some very fine-grained control over compiler options, so users get the possibility to optimize their packages for the respective compilers. And we are still looking into how to best support optional dependencies and variants in Fortran with this tooling. And with this, I want to close. If you're interested in our Fortran community, visit us at any of those sites. And I'm happy to answer your questions.
Okay. I guess, let's see. I don't see any questions in the chat. If I'm missing some, then folks ought to paste it. Let's see.
Yes,
and so I guess I have a question, which is, there's a lot of people talking about the last talk still. Yeah. So I guess I have a question. What kind of solver does FPM use internally how does it do dependency resolution?
So right now, we haven't really explored how to deal with registries yet. And of course, we don't want to write our own solver in Fortran, but use something that we know is working. And I think maybe a good choice would be to look into libmamba. Maybe we are able to interface this easily because Fortran quite straightforwardly binds to C, which would allow us to leverage a lot of knowledge which is already there.
Okay, thanks. Let's see. I mean, are there any special semantics that you would have to deal with Fortran packages that aren't really dealt with by libmamba right now?
Main issue is probably that we have to deal with the Fortran IB issues. So, just to make sure that we are not able to mix different Fortran packages compiled with different compilers to keep those cleanly separated.
Mm-hmm. And I guess are there a lot of Fortran packages that depend on C libraries and other sorts of things? And what's the strategy for integrating those into FPM?
So for one thing, we can actually build C. So if you would, you can use FPM as a C package manager, and we are also able to build C++. So in principle, it could be abused as a C or C++ package manager, but we don't really want to port the whole world into the FPM ecosystem. So we are looking into a way to seamlessly integrate with something other build systems and get a way to maybe just build a CMake project or depend on a system package.
Okay, let's see. There are some actual questions in the chat now. Put one in here. All right. Vis-a-vis Fortran packages, I'm looking at your package index, and I do not see some of the ones that I sometimes have to use, like IRA and AnyQuick and IGRF. Did I miss it, or have they not been ported?
We just started. Not all packages are yet available with FPM, so we have around 200 now. But porting a big library to a new build system is kind of a difficult task. And if they have something that works, AutoTools or CMake, they're probably happy with this. So we're more looking into also supporting in that way. Or maybe getting the capabilities for FPM to actually generate those CMake files that the project can use FPM, but they stay with their original build system as well.
Okay, I guess I have, so on that question, you don't have to use FPM's prescribed build system for FPM? What do you do if you're a project that has a legacy build system? How do you typically maintain, how do you move to FPM, or how do you support it?
So one thing we want for FPM is to have it work out of the box. So if it has the layout the right layout, you just put the name of the project in, then it compiles. Then of course you have to check if you have to link libraries and stuff like this. We are looking into a way to automatically generate a full CMake build system following some CMake best practice for Fortran projects, which makes it easy to reuse from non-FPM projects, and maybe also easier to integrate with existing package managers rather than having to integrate add something for these package managers to actually understand and drive FPM.
Mm-hmm. Okay.
We're really open for ideas and inputs on this.
And then I guess, okay, so we're out of questions in the chat. I'll just keep asking stuff because I'm curious from the stack perspective. How are you so you don't currently allow people to mix compilers. What is the compiler model for FPM? Like, do you pick a tool chain up front, sort of like Conan, or what's the model there? How do you pick a compiler?
So what we're currently doing is, if you give us a compiler, we're going to kind of namespace the build we're doing for this compiler. And if you're changing it, this is going to change the namespace of this build. So if you can seamlessly switch between a compiler if you're specifying it with FPM. As long as you're in FPM, of course, this is not a problem, but after you're installing it, then we have to deal with this. So in most cases, if you're developing an application, this is nice and easy. If we're developing a library, there has to be a model to distinguish this. But the unfortunate thing is, unfortunately, install it's on the same level as C. So we're not sure yet how we can maybe install a system prefix for two different Fortran compilers and then maybe mix this.
So does it use separate directories for each different
Yes.
build of a package, or is it okay? And
so we can separate compilers.
Go ahead. Mm-hmm.
But
so okay,
of course, after we install, yeah.
Go ahead.
So
I have another question about runtime. Okay. Oh, go ahead. Sorry, there's a lag. I'm going to shut up. You finish the question, the comment.
Yeah, and just after we're installing the system prefix, this information is unfortunately lost. But I don't know if there is a way to actually do this.
Okay. So I guess someone is asking, how does FPM handle third-party code dependencies? I assume it's doing some dependency management, but you did say that it's not doing solving yet. So do you have dependencies in FPM right now?
We have some very rudimentary dependencies where we're depending on Git repositories and using the Git hash information for managing. We don't really have solving. We can link against system libraries, but we need to do more in this direction.
Okay, and I have a follow-up question on that. Okay, so if you can link against system libraries, what is a system library? How do you draw that line? And moreover, with the different compilers, what about things like compiler runtime libraries? So like if you do GPU offload or if you do OpenMP with Fortran, there are a lot of libraries that come into play that can even be conflicting between multiple builds by the same compiler. So how do you answer those questions? Like how do you deal with system libraries and compiler runtime libraries?
Yeah, for one, we currently kind of relying on the compiler wrapper around the linkers, handling most of the stuff. If it comes to linking specific libraries, we don't really have a solution yet for this.
Okay. Any last comments or questions? I think that's all we've got from Element. So thanks a lot. This is a really cool project, and thanks for presenting.